Graphing quadratic inequalities is going to be, we're going to kind of combine how we graph a parabola, how we graph a quadratic, and then we're going to do the shading. So let's review real quick how we graph a linear equation. We have this inequality here, y is greater than negative 2x plus 3. Remember, if we wanted to graph this linear equation, we start by graphing y equals negative 2x plus 3. Since this is in slope-intercept form, our y-intercept is 3. Our slope is a negative 2, so that means I go down 2 over 1. So now if we're going to graph this line, remember it has to be a dashed line. So, oops, not that big. But remember, we're graphing this line, and since it's greater than or less than, it's a dashed line. Greater than or equal to, less than or equal to, it's a solid line. So since it's greater than, it's going to be a dashed line, and that's what I'm attempting to do over here. Now, we're not done there because we've graphed the line, but it's an inequality. So we need to shade one side or the other. The way we do that is to focus on our inequality. We're saying y is greater than negative 2x plus 3. So you pick any point not on the line. I like to use the point 0, 0. My x value, my y value. Now plug it in for x and y here. Is 0 greater than negative 2 times 0, because that's my x value, plus 3? Is 0 greater than, negative 2 times 0 is 0, plus 3 is 3. Is 0 greater than 3? The answer is no. So this point here is not a solution, so you shade the opposite side of the line. Okay? So this is how we graph a linear inequality. It's the same concept for graphing a quadratic inequality. So here's your rules. The first thing you need to do, step 1 here, is sketch a graph of the equation, just like we did here. We graphed the equation. Sketch a dashed parabola for inequalities less than or greater than, same thing. Sketch a solid parabola if it's less than or equal to or greater than or equal to. After you sketch the parabola, then you test a point. That's what we did right here. We tested 0, 0. And you always like to use 0, 0 even for quadratics unless 0, 0 lies on your parabola. And then you shade one side or the other, and that's what step 3 means. So let's look at an example. We have y is less than or equal to negative x squared minus 5x plus 4. So the first thing we're going to do is we're going to graph y equals, I'm going to put a negative 1 in there, x squared minus 5x. Actually, I'm going to write that as plus a negative 5x plus 4. Think back to when we graphed, excuse me, think back to when we graphed inequalities. Think back to when we graphed quadratics. We need to find the middle. If looking at this, since this is negative, we know our parabola is going to open down, but where is this middle? The way we find out where the middle is we use negative b over 2a. ax squared plus bx plus c. Okay, so using that, I end up with a negative 5 over 2 times a negative 1. Negative 5 is a positive 5. 2 times a negative 1 is a negative 2. That's equal to negative 2.5. That tells us the x value of our vertex. So when I make my input-output table, I'm putting a negative 2.5 in the middle. And then you select a couple values on each side. I'm going to use negative 4 and negative 5. And negative 1 and 0. So now just plug these x values, remember these are the x's, your inputs, and these are the y's. Plug them in for x right here. Okay, so if I were to put in negative 1 times negative 5 squared plus negative 5 times negative 5 plus 4, remember for this right here, put it in parentheses. Negative 1 times negative 5 squared. If you don't put it in parentheses, it won't square the negative 5, it'll just square 5. Plus negative 5 times negative 5 plus 4. When you put that into your calculator, you get out an answer of 4. If I then substitute negative 4 in for all of these, I get an answer of 8. Negative 2.5, I get 10.25. Negative 1, I get 8. And 0, I get 4. Okay? So now what I'm going to do is I'm going to graph these ordered pairs, and they should look like a parabola. So our vertex is going to occur right here in the middle. So at negative 2.5 and positive 10.25, that's just a little bit above the 10 here. Then I had negative 5, 4. I had negative 4, 8. I had negative 1, 8. And I had 0, 4. So we can see a parabolic shape. So what you're going to do now is you're going to draw a parabola through it. Doing the best you can, as always, do better than me. Oh, especially right up there. Erase that and lose my point. Sorry, guys. Okay, so you should get something that looks kind of like this. Oh my goodness. Sorry about that. So it's coming down, and we're just going to go with it. Oh my gosh. Sorry, guys. Obviously, I'm struggling with this part because I made my graph too big. There we go. It's a little bit better. Anyway, that's how we graph this. Except, I should have checked this before, but notice that it is less than or equal to. Just like originally, that means it's a solid line. Okay, so we can leave our parabola here a solid line. But we're not done yet. Since this is an inequality, we're going to have to shade one either inside or outside. So since 0, 0 isn't on the graph, we can test the point 0, 0. So what you're going to do is you're going to go back to your original, right here, and you're going to test the point 0, 0. Okay, so I'm going to use 0, 0 because it's not on the parabola. And I'm going to say, is 0 less than or equal to negative 0 squared minus 5 times 0 plus 4? Is 0 less than or equal to, well, the negative 0, or 0 squared is 0, that's still 0, minus 0 plus 4. Basically, is 0 less than or equal to 4? And the answer is yes. 0 is less than 4. Okay? Since this is a true statement, that means 0, 0 is a solution. Since 0, 0 is a solution, do we want to shade outside or inside the parabola? We want to shade where 0, 0 is. So again, very similar to graphing linear inequalities. You graph it, you decide whether it's a solid or a dashed line, and then you shade either one side or the other. In this case, you shade either inside the parabola or outside the parabola. Okay, so don't forget your rules of how we graph quadratics, and then test a point, hopefully 0, 0 unless it's on the graph, and either shade inside the parabola or outside the parabola.